Well, let's talk about solid waste disposal. This is something you probably were thinking of when you signed up for this class. I mean, when people think of environmental science, they often think about garbage. So, well, let's get dirty and talk about garbage. Okay, so when we say solid waste, what we mean is basically any anthropogenic waste product, any human generated waste product that isn't liquid or gaseous. So we're not talking about sewage. We're not talking about things come out of smokestacks. The rest of it is called solid waste. And it can be generated a number of ways. Okay, so what you and I encounter in our day to day life is basically what we would call domestic waste. Okay, so this is just people in the course of their day have packaging and leftover food items and things like that they have to get rid of. But there's also industry generates waste, so do farms and other agricultural endeavors. Businesses do mining operations. There's lots of sources of it, and let's just take a look at how that breaks down. So, and different countries are going to have different ones. This is, I think, a European one from 2016, but it just gives us a general sense of it. So we look, construction, manufacturing, mining. That's the bulk of it. Now, but you and I, we contribute a bit, okay? So, and everybody should do their part. But you can see that most of it is coming from other sources. But let's just talk about this part because this is what you and I have a bit more say over. Okay, so if you do, so what would you call it? Like a autopsy of a garbage can. Okay, what you're going to find is a certain amount of stuff in it. Okay, so by volume, what we find is basically this is how it breaks down. So it's the bulk of it tends to be paper, which tends to take up a lot of space. Food, in places where they have yards like America, yard trimmings are quite a bit. Wood from building things and metals from building things. Plastics take up a bit of room, as does glass. So now what happens is, for the most part, what we do with it is we just put it in a bag, take it out to the street, and someone takes it away, and we never think of it again. But I assure you it has to go somewhere, right? Hey, don't forget, we have the law of conservation of matter. Matter can't be created or destroyed. You created some trash, it's not going to get destroyed. It's going to go somewhere. Usually here's where it goes, to a garbage dump, which we would call a landfill, which, it's kind of funny. It's sort of an oxymoron. They're called sanitary landfills. And I can't think of many things that are less sanitary than a landfill. It's kind of a funny term. A lot of times we just call them municipal landfills. Okay, now there are three main problems associated with landfills. Okay, and they may not be immediately obvious, but maybe they are. Okay, the first one probably is, look, some of the stuff that gets dumped in here contains things that are toxic. Also, there's what we call leachate, this liquid that comes out of here, and over time, methane is generated. So let's look at each of these problems in turn. So the first one, let's talk about toxins. Okay, you know what? In your house, you have things you throw away that are toxic. There's leftover cans of maybe spray paint or old headphones or batteries or leftover pesticide or whatever. So there's so many things. The fluorescent light bulbs. There's so many things that we throw away that have toxins in them. These toxins are things like heavy metals mostly, or it could be pesticides and other substances that are designed to be like endocrine disruptors. It turns out e-waste is a real problem. So e-waste is things like phones, computers, iPads, TVs, things like that. Well, the problem with these is often this technology that we so love, it involves heavy metals, and so these heavy metals, they just end up in this dump, and then they eventually become mobile by interacting with water, and then they get out. So if we don't take precautions, what the worry is that these toxins end up in groundwater. And this has certainly been a problem in the past. Now, modern landfills have a way of addressing this, but we'll get there eventually. But that's the real concern, is that these toxins can leak out, whether these be like heavy metals or different endocrine disruptors. Now, leachate. Basically, this is the disgusting gooey liquid that forms in the bottom of landfills. So you just think, it happens in your own garbage can at home. You just look at the pipe and say, "Oh, gross! What's this?" Okay, well, so it's imagine making this mountain of trash. Stuff is just going to start leaking out of it, and then make matters worse, rainwater can infiltrate, especially during storm events, and then as that water goes through there, it's going to end up getting some of the material in there to mix in with it, and it ends up at the bottom of this gooky, nasty stew at the bottom that has heavy metals and toxins and all these things in it, and it's liquid. So it's really, if you don't plan for it, it's going to get into the groundwater and the surface water and out into the environment and cause a lot of problems. Now that's a point source, so it's possible to mitigate that, which is a good thing. But leachate is probably, I would say, one of the the biggest problem. Okay, but another one that may not be immediately obvious is methane. So methane is just CH4. It's what's in your stove at home. If you have a gas stove at home, that's methane gas that you're using. Okay. Now most methane gas that we use in the world comes to us out of oil wells. It's one of the many components of crude oil, and so we pipe it into people's houses, whatever. Well, methane, here's one problem with methane. Okay, so methane is 20 times, you take two molecules, a methane molecule and a CO2 molecule. What we find is methane is 20 times more likely to absorb infrared light and re-radiate it. So in other words, it's 20 times more effective at producing a global warming phenomenon. So, it takes 20 carbon dioxide molecules in the atmosphere to equal the global warming effect of one methane molecule. Now, we produce a lot more carbon dioxide, so that's really what we tend to focus on when we get to that part of the course. But methane is a serious second contender. And so it turns out it's generated in landfills. And the reason is it's produced by anaerobic respiration. So in your trash, you've got all kinds of bacteria. There are bacteria everywhere, okay? You can use all the antibacterial substances you want. It always says get rid of 99.99. Yeah, well, it didn't get rid of all of them. So just like that, they come back. Now, here's the thing. So when you throw this stuff in a plastic bag, let's start with that, and then you put it in the ground, you put dirt on top of it, there's not a lot of oxygen in there. There's a little bit of air in there to start with, and the aerobic bacteria immediately begin to do their thing and decompose the food waste and the other organic matter that's in there. But they quickly end up breathing up all the oxygen, just like you would. And now there's no more oxygen, so they die. But now you got the anaerobes, and the anaerobes are like, man, I don't need oxygen. I'm just going to eat this garbage here. Now they're not nearly as efficient. So for the most part, once the aerobic bacteria have suffocated, the rate at which the material in the landfill decomposes is greatly slowed. They talk about finding hot dogs that are decades old that are still not decomposed. Okay, but these anaerobes, the way they operate is instead of breathing out carbon dioxide and water like you and I do, one of the things they breathe out is methane. And so methane is always produced by the anaerobes in these garbage dumps. And it can be a real problem, not just as in terms of global warming, but in terms of other problems it can produce. So let's just take a look at this. This is pretty stunning, really, if you look at this. Okay, so where does the methane in our atmosphere come from? Well, 28% of it, as we talked about earlier when we were talking about farming, comes from cows and other ungulates, the ones that have that stomach in the front where they have bacteria. They have these anaerobic bacteria that help digest the grass for them. Okay, 28% comes from that. 28% comes from natural gases. So when we build oil wells, is part of oil, so it tends to leak out. They used to just burn it. Now they try to capture it, but a lot of it just leaks out. But look at this: 15% of it comes from landfills. That is significant, people. That's a lot of methane. And that's something we should be concerned about. That's a serious slice of the global warming pie. And so it was things that we just didn't know about, and now we know about it, and now we know how to deal with it. Okay, so let's just look at the anatomy of a landfill. How do we deal with this? Okay, so I'm going to start by talking about the anatomy of an old school, wrong way of doing things, old school way of doing things before we learn better. And that's the name of the environmental science. It's always like, look, we did what we thought we should do, and then we realized, man, that was a terrible idea because it's making all these other problems. And so now we've addressed it. We've found ways of mitigating the problem. So let's just look at this. Older landfills, all they were a hole in the ground. You just dig a hole, you throw your trash in it, and once it fills up, you put some dirt over the top of it. Unfortunately, a lot of times you sell it as a neighborhood. Like near my house back in Washington, there's this area, and my friend's like, yeah, see this house over there? When I was a kid, that was a garbage dump. Okay, so which hey, as long as it's safe, that's great. There's no reason it should be unusable land afterwards. But that's all it was. It was a hole in the ground. You threw trash in, you put dirt on top of it, and you sold the land again. Okay. The problem with these they really led to terrible contaminations of groundwater and surface water and emissions of methane gases. I had a friend, her job was to go and try to evaluate how much environmental harm was caused by one of these. She went to one of these neighborhoods that was built on top of a garbage dump because people were complaining about the effluent, like the leachate leaking out of it and making the nearby stream smell bad. And when she went to investigate it, she passed out because she'd gotten into like this cloud of methane, and she basically, there was no oxygen. She passed out. She could have died. So that's how they used to do things. Okay, so this is a picture of an old school one. So basically, you dug a hole, right? You threw in all your solid waste. You just put some soil over the top. You just, the soil that you dug out, you just threw over the top. Made sense, right? Okay, now it's out of sight, out of mind. We don't have to deal with it. The smells aren't so bad, right? But here's the problem. This is not impervious, so water just leaks through, and you just get this buildup of leachate. And so the leachate just moves directly into the aquifer because the bottom is just open. So anything that comes out of this is just going to go straight into the groundwater. So you end up getting, all kinds of god-awful toxins that you don't even know what they are, because you think about it, every bag has something different. And so you have no way of accounting for what's there. You just end up with a problem later on, and it's really hard to fix. That's how we used to do things. That's not how we do things anymore. Okay. So the anatomy of a new landfill, they're actually pretty cool. They're totally engineered, and they're pretty awesome. Okay. So a modern landfill has the following safety features. First of all, the bottom isn't just open to groundwater. It's got an impermeable bottom. So it's got either a heavy plastic lining or a clay lining, or both. So the idea is we're going to prevent that leachate from getting into the groundwater. That's the most important thing we can do to protect the environment near a landfill. The second thing is we're going to put in some sort of plumbing that allows us to pump out leachate and stormwater when it gets in there. So we don't want to overflow this barrier, right? So we have to have a way of getting that leachate out and then mitigating it somehow. You're dealing with it somehow. Okay, that's a whole nother issue. All right. We also need a way of capturing the methane. There's going to be methane generated. We need to capture that methane and do something with it. Then we also, instead of just taking the dirt that we pulled out of there to make it and throwing that back on, well, that dirt is often, just it's totally, permeable, right? It has pore space. It's got permeability, so it just water goes through it. Instead, we're going to put something on top that stops that from happening. We're going to have a cap that's actually an impermeable cap, or in some cases, they can put a material into it that is able to oxidize the methane and turn it into just carbon and hydrogen, or carbon, I should say. Probably carbon dioxide water, actually, now that I think about it. And then the other thing is, we're not just going to trust that it works. We're going to put wells around it that monitor, so we can monitor the groundwater and see if we're starting to get leachate leaking into it. Because if we are, we know we got to do something to fix it. And that's a totally, totally different situation here. So let's just take a look at these modern landfills. So we have this heavy, impermeable system to protects it from leaking leachate into the groundwater. Then we have a leachate collection system here that we can pump it out and deal with it. We also have a way of capturing the methane gas that's produced and pumping that away and dealing with it. And then to make sure that we're not ending, we have a cap on it that is not going to let water get in. And on top of that, we can put grass, and we can still make it nice afterwards. Okay, but we're not just going to pretend it's not there. We're going to have systems in place to deal with the leachate, to deal with the methane, and to check to see that we're not harming anything. So what we do is we put in these monitoring wells so that we can see if the groundwater is becoming contaminated. And if it is, we know that there's a problem with this, and we have to remediate. So that's what we do now. It's expensive, and you know what? It really protects the environment, and it's kind of cool. Here's just another vision of this, a little bit easier to vision. I think I just kind of like this one. Okay, look. So we're gonna have this impermeable barrier here at the bottom, and one on top as well. By the way, we're going to be able to pump out the leachate and deal with that. We're going to pump out the methane and deal with that, and we're going to have a well down here into the aquifer, so we can make sure that nothing's leaking through here and getting there. That's what a modern landfill looks like. By the way, when it comes to modern landfills, one of the most awesomely engineered one is the Nunjito one, which, if you haven't seen, it's right here in Seoul. It's funny because I was going through this presentation I'm making up, and I saw this picture. I looked at this picture and I knew exactly what it was. I'm like, I've been there. So it's not like I went to visit this garbage dump, this landfill. But my wife and I did this cool hike called the Seoul Trail Hike, or the Seoul City Hike. And it basically goes all the way around Seoul. It's like 160 kilometers, kind of going around the outside of Seoul. And at one point you like cross the Han River and you're going by these mountains, and you start noticing like these monitoring wells and these methane pumps, and it's like, whoa, this isn't a mountain next to us. I mean, it seems like a mountain. It's tall, but it's actually it was an old landfill that's no longer used. And I just want you to see like just the amount of engineering that went into it is just phenomenal. Okay. And it's all about trying to catch this leachate and keep it from getting into the Han River, trying to keep it from getting into the watershed through our aquifers or surface water. Okay. And they're quite successful at it, but it takes planning. So here it is from Google Earth. So my wife and I, we got at the station here, we walked across, and then we came this way, and we were like, whoa, look at these, this is awesome. And then this is World Cup Stadium here. And so this is basically, this for a long time was where all the trash in Seoul went to, and then they had a way of dealing with it. So modern landfills are effective at protecting the environment. Now, what's interesting is a lot of people are going, oh, wait a second, we got this methane. Methane, you can burn it, and it's basically a lot of our modern electrical generating facilities. Instead of using coal, they're using natural gas. Natural gas is just a fancy word for methane. So people are going like, well, why can't we burn it here? So basically what you can do is, they're calling it landfill gas. That landfill gas happens to be methane. You collect the methane. You basically clean out any impurities that it has, and then you burn it. You make steam. That steam turns a generator, and you make electricity. Yes, you're releasing carbon dioxide in the atmosphere, but you got to do something with it. You might as well make some electricity out of it. Now, in some places, what people do is they just burn the trash. They're like, well, we don't have the land space to make a landfill, or we don't want to spend the money on a landfill where we have to monitor, for all times. So let's just burn the darn stuff. Okay, well, I think you don't have to be a genius to see the problem with this. Okay, yes, you won't have a big mountain of garbage that has to be engineered and monitored for all times, but you're going to be putting a lot of pollutants in the atmosphere. There's no getting around that. I mean, unless you have some Mondo scrubbers here, which you're then going to have to collect the stuff and put it in landfill. It is one method of reducing the volume of it. Okay, it leads to more air pollution. It leads to more carbon dioxide in the atmosphere, but it is something that a lot of countries do. India does that a lot. And here's just kind of a close-up. I just want to point out here, Casey, we're going to dump the garbage in here. We're going to burn the garbage. Okay, now look what's happening now. That heat, I'm going here. I have a heat exchanger, so I'm going to boil water and make steam. Is that sounding familiar? And then that steam is going to turn a turbine, which is going to spin magnets, which is going to make my electricity. And then I'm going to take that steam, I'm going to cool it back down into liquid water that I can reboil. And then I'm going to have to put in a cooling tower. Oh my goodness, now look what I have. What was that called again? Oh yes, thermal pollution. Okay, so this is a viable method of making electricity by burning garbage, not just the methane, but the garbage itself. And you do have leftovers, but a lot less. You have this, what they call bottom ash, that you didn't have to then put in a landfill. But this is something that municipalities look at. One of the problems with this is, though, we don't know what's in it. I don't know what you threw in your garbage, right? So if you threw in something that has cadmium in it, well, there's probably going to be cadmium coming out of the smokestack, and that's not a good thing. So there's a lot of people who are not really very keen on this, but there's other countries that really want to pursue this. Unfortunately, there's a number of countries. I'm just going to name some of the bad countries for this, okay? So China's bad about it. Indonesia's bad about it. The Philippines is bad about it. Vietnam, Thailand, those are the big offenders. These 5 countries in Asia and Southeast Asia, they just dump their trash in the ocean. I mean, they used to do this in New York City. They just take trash off. But the Navy was terrible about doing it, right? And then they got shamed out of doing it. They quit doing it. But these countries will just take it out and just dump it in the ocean. Tragedy of the commons, like you wouldn't believe, right? It's not my ocean, so I'll just dump it in there. Well, okay, obviously it's going to put a lot of toxins in the ocean, which is a terrible thing, okay? And a lot of plastic and styrofoam floats, and it's not very decomposable. It doesn't biodegrade very well. It doesn't photodegrade. Most of it doesn't degrade at all. So it just sits there in the ocean. And you've probably heard about this, but you get these big plastic floating islands. So there's these trash islands where these circulation patterns, these gyres in the Pacific, tend to make it accumulate. And so there's these two really large trash islands in the middle of the Pacific that are largely due to those 5 countries dumping the trash. I mean, it comes from other places, but those ones are just dumping municipal trash right in the ocean. Okay, last thing I want to say is this. Okay, so the people who are in charge of landfills, they want to protect them. They don't want to be responsible for if their leachate gets out. That's bad enough, but they don't want it to be full of things like pesticides and lead and things that are really going to get them in trouble. So they go, hey, you can't put that in the garbage dump. You know, a lot of municipalities says, no, you're not allowed to get rid of it. Well, here's the thing. If you're selling people stuff and there's leftovers, what are they going to do with it? It's got to go somewhere, right? And if you won't let me throw it in the dump, you know what? Most people are just going to go, well, I'll just throw it out in my yard. You know, fines, I'll just throw it on the roadside. So it's a terrible thing, but that's just the way people are. And so it's not a solution to just say you can't do it. You have to provide people with an option. Best thing to do is just include the disposal cost in the sales price. When you buy this product, you are also paying for the cost of disposing of it. So the municipality will just take it from you and deal with it. Now, I'm just going to look at 2 cases. Okay, one thing is tires. You wouldn't think of this, but tires are a problem. They really don't want them in landfills. They take up a lot of space, and landfills, they're expensive, so they don't want to fill it up with these volume taking up tires. So obviously, you can't bring tires here. Well, okay, so what happens is people burn them. And if you've ever seen a burning tire, it makes this awful black carcinogenic smoke. It's just terrible. Okay, everything you can imagine wrong with air pollution is right there. All right. Or people just throw them in the woods or on the roadside. And then what happens with tires is water gets inside them and fills up. And it turns into a breeding ground for mosquitoes. And if you're in a tropical environment, you're getting all these are disease vectors for spreading things like malaria and Zika virus and other things. And then the other thing is people, they get rid of pesticide cans, paint cans, batteries. They'll just throw them in the woods, throw them on the roadside, and those things now are going to, leak. The containers are going to leak, and then the heavy metals and these endocrine disruptors are going to get into groundwater, into the surface water. The problem now is, unlike a landfill, which is a point source, which I can mitigate, I can monitor and mitigate. I can't monitor and mitigate when these things are scattered on every roadside in the country. And so, really, this is a terrible strategy. It is really absolutely vital that countries have in place mechanisms for collecting all this waste, especially tires and toxic waste. Okay, sorry that was a little bit longer than I thought it would be, but thanks for listening. And now I've got to go through this whole thing about how to turn this thing off. It just drives me nuts. I know I say that every time, but every time I go to turn it off, it makes me mad. Bye.